Okay. So today we're going to do something called implicit differentiation. Up until this point, we have differentiated functions in the explicit form, which means solve for y. All right. So explicit means that your guys are solved for y. Implicit means you're not in y equals. So that's kind of the difference. So we're still taking the derivative, but you're going to take the derivative of stuff that looks like this. So do you see how on example 5, how it says y cubed plus y squared minus 5y minus x squared? You've got x's, you've got y's. They're all mixed together. Okay, so that's the difference in the type problems that we have.
Okay.
All right, so what we're going to do is anytime you differentiate a y term, which means a term that has y in it. Anytime you differentiate a y term, you have to multiply by dy dx. All right, so anytime you differentiate a y term, focus, you have to multiply by dy dx. Now, dy dx is the notation for derivative. So don't get confused. This is the notation for derivative. So if your question says find dy dx, it's saying find the derivative. This is the same thing as y prime. It is the derivative.
Are you recording?
Yeah.
What? You are?
That's why it's lagging a little. All right, I'm going to pop back up to the guidelines for implicit in just a second. I want to talk about just the basic differentiation. So if you notice in front, and we've seen this little symbol before, the ddx, this means we're differentiating in terms of x, all right, which is why in the past couple problems that we've done, when you've taken the derivative of something that has an x term, this one would be 3x squared, you didn't put anything after. Because if you differentiate this guy in terms of x, if you times it by dx over dx, well, that just goes away because it's just a 1. Right? Dx over dx is just 1. But if you differentiate a y term in terms of x, the derivative of y cubed is going to be 3y squared. But it's a y term, so we have to multiply it by dy dx, which does not go away.
Oh, that's the answer?
Mm-hmm.
It gets harder when you've shown it.
A little bit harder. Not too bad, though. Okay, so let's talk about where we have x's and y's. So we're differentiating in terms of x. So what's the derivative of x? 1. And it's an x term, so it's just 1. We don't have to do anything special with it. It's an x term. What's the derivative of 3y? 3. And then because it's a y term, we're going to multiply by dy dx.
You're just adding random letters to your answer and calling it a
Yeah.
day.
What does it mean? Like,
We don't need to know.
Well, I'll explain a little bit more. For right now, let's just get the math part down. What rule am I using on this one? Product rule, because you're multiplying the x and the y together.
2xy. Oh.
All right, so
X and then the derivative of the
First-
y, which is 2y. Sorry, and plus.
hold on, 2y times dy dx. All right, so hold on. Let me explain what I'm doing right here. So I'm doing product rule. So this is the first function. The first function is just plain old x. This is the derivative of the second. And when I'm differentiating this y term, I have to multiply by dy dx because it's a y term, not an x term.
But
Then-
when you're not taking the derivative, do you have to put dy dx or no?
No. Yep, so the second term, we just write normal. We're not differentiating. We don't need to put dy dx. We just write y squared.
And just 4.
And then the derivative of the first term, which is just 1, and it's an x term, so you just put 1. You don't need to put dx dx.
Circle it.
Yeah.
Dang. So this is one of your FRQs?
no.
I'll explain.
Oh.
Just wait. Okay,
Wait for it.
So, just looking forward, you are going to differentiate in terms of other things. So we don't always differentiate in terms of x. So eventually, we are going to, why is it not working now? We are going to differentiate in terms of time when we get into real life scenarios. So when you're differentiating in terms of time, everything is going to get like d something. So if I differentiate x, what's the derivative of x? 1. And so I would put 1 dx dt. Because now I'm differentiating in terms of time, not in terms of x. So the letters don't match up. You got to put a d whatever.
So you can just put the dx dt. You don't have to do this if you know.
Right, yes. Mm-hmm. And then plus, what's the derivative of 2y? 2 dy dt. All right, so looking forward when we get into our like real life application unit, we're going to have a lot of DTs because we're going to talk about a real life scenario that's in terms of time. And so the derivative tells you what? The slope.
Yeah.
What's another word for it? It's the something
Overrun.
instantaneous rate of change, which all of you are right. It is slope. It is the instantaneous rate of change. It is a derivative. But when you talk about real life scenarios, when we talk about the derivative, this is going to be the instantaneous rate of change of y. And this will be the instantaneous rate of change of x because it's the derivative of x in terms of time. And this is the derivative of y in terms of time. Does that kind of make sense a little bit? A little bit. It's just the notation, so try not to get lost with the notation. But we're going to see the DTs later. So right now we're going to focus on the dy dx's. All right, so let's look at example 5. So this is what your problems are going to look more like. You're going to have an equal sign, and your question's going to say find dy dx. So when it says find dy dx, that means find the derivative.
Do you move the 4 over?
Not yet. All right, so Elijah, leave my drawers alone.
I am.
If you weren't a calculus teacher, when would you ever use this?
You do use the, like, when we start doing related rates, you'll see the real life application.
To see how long it takes to get to the hospital after you get hit by a car.
Yes.
Because you have to go to school.
All right, so dy dx is the derivative. So this is telling me to find the derivative. Because your equation has y's and x's and it's all mixed together, you have to use implicit. All right, so we're going to start with the y cubed. What's the derivative of y cubed?
3y dy dx.
3y squared dy dx.
I'm just going to say
Dx.
All right, plus, what is the derivative of y squared?
2y times dx.
Mm-hmm. Minus, what's the derivative of 5y? 5.
dx.
Mm-hmm. And the derivative of x squared?
2x.
That's it, just 2x. Mm-hmm. And then the derivative of negative 4.
0.
0.
All
All right, so
circle it.
no. Okay, so we gotta find dy dx because that's what the question asked for, was to find dy dx. All right, these other ones was just differentiate the term. All right, that's the difference here. This is take the derivative of this term. So we were done. This one here is we want to figure out what dy dx is. So we want to get these dy dx's, we want to get it by itself. So this is where your guidelines from up here, this is the steps that I'm going to do on these problems. So we did step 1, differentiate both sides with respect to x. So we did that, and we put the dy dx in all of the y terms. The second step is we're going to collect all the dy dx terms on the left side. Anything that does not have a dy dx gets pushed to the right. All right, so I'm going to come back down here. All right, so this has a dy dx, this has a dy dx, this has a dy dx. Mm-hmm. So we're going to move the 2x to the other side.
So is every problem going to take this long to do?
No. And you'll get faster at it because it's a lot of algebra. Okay, so the 2x doesn't have a dy dx. That's going to get pushed over to the right side. So I will add it to both sides, and it'll equal 2x. Now, the next step, if you look at your guidelines, is going to be to take a GCF out. Because what do all of these guys have in common? A dy dx. So you can take a dy dx out, and that is the only GCF you want to take out. So if there's like a number in common, don't take that out. All right, you're just taking the dy dx out. So we're going to take a dy dx out, and you are left with 3y squared plus 2y minus 5 equals 2x. So once you've taken the dy dx out, remember my goal is to get dy dx by itself. So what am I going to do? Divide. Yep, so divide by whatever is in these parentheses.
Wait, why?
Because you're trying to get the dy dx by itself. So we're going to divide by this to get rid of it.
Okay.
All right, so that's going to go away. So dy dx is going to equal 2x over 3y squared plus 2y minus 5. And now dy dx is by itself, and so that's my derivative. Your derivative will have x and y in it. That's okay because the original problem had x and y in it. So when you're doing implicit, you should have x's and y's in your derivative.
Are we doing example 6?
Mm-hmm.
I used a lot of the room.
Example 6 is a lot shorter. Okay.
Ready.
So first we're going to take the derivative because that's what dy dx means.
2x plus 2y dy dx.
So 2x plus 2y dy dx equals
0.
0. All right, what do I want to move?
The x.
The 2x. Yep. So minus the 2x to the other side. Now, yeah, on this one, I don't need to do the GCF step because it's just the one term over here. So we can go straight to dividing.
Divide by 2y.
So dy dx is going to equal negative x over y because the 2's will reduce. All right, does it kind of make sense?
Yep.
Okay.
Slope of the tangent line. Yay.
So that's kind of the process, but now we're just going to incorporate some different kind of vocabulary and some different kind of style questions, but the implicit is the same. So on this one here, it says determine the slope of the tangent line. What does that mean, slope of the tangent line? Say it again?
Y minus y1.
Yeah, the derivative. Slope. All right, so the slope of the tangent line is the derivative. So the derivative, slope of the tangent line, instantaneous rate of change, dy dx, y prime, all of these things mean derivative. Derivative. So this is going to be, I need to find the derivative. And once I find the derivative, I'm going to plug in my values to get the slope. All right. What is the derivative of? Yep.
2y dx
Okay, 2y dy dx
minus 2x.
equals?
Oh.
No, equals 0.
Yes.
I mean, I wrote 0.
All right, what do I need to move?
The plus 2.
What?
The plus 2,
It's a minus
yep,
2.
the plus 2x, the x.
It's going to be negative x over y.
Yep.
Yeah. It's going to be negative 1.
Cameron, let us get
All
to
right.
that step, please.
All right, so hold on. So we're going to add the 2x over to the other side. This is another one where it's just the one term, so I can divide by the 2y.
Then you plug it in.
And so then your derivative, the 2's will reduce. Your derivative is x over y.
1.
And the point that we're plugging in is 2 comma 2. All right, so that was given in the problem. And so when you put 2 divided by 2, your slope is going to be, yep. All right, but you need to know that the slope of the tangent line means derivative. and then you plug in your point. All right, go to number 9. Okay, number 9 says find dy dx. This just means find the derivative. That's all you're doing on this one. Dy dx is the derivative. So what's the derivative of sine? Cosine. It's going to be cosine of what? Y times dy dx equals 1. So when you're doing trig, the inside stays the same. So the derivative of sine is cosine, but this inside here, the y stays the same. That's why the implicit is like chain rule, because the inside stays the same, and then you times by dy dx. And so then to get dy dx by itself, we are going to divide.
Okay, why does it become
1 over cosine is
So yes, your answer 1 over cosine of y, but if this was multiple choice, they probably would write that as secant y. And that's just one of the trig reciprocals that you learned last year.
And then you plug,
That's it.
Yeah,
Oh,
'cause you
period.
can't
Yep.
figure out secant.
Yep. Yep. So that one was just find the derivative. So once you find the derivative, you're done. You don't have a value they gave you to plug in. Okay. On 8, it says find the tangent line to the graph of x squared plus 4y squared equals 4 at the point 1, 2. So if you're trying to find the equation of the tangent line, what do you need?
MXY.
Yep, m, x, and y. What is your x value?
1,
What's your y value?
2.
How do you find your slope?
You get the
Derivative.
derivative and then plug the points in.
So what's the derivative of x squared? 2x. What's the derivative of 4y squared?
8y times dx.
Yep. Equals 0.
I love how any of the videos just gonna hear from the same video.
I stole it from Elijah.
Okay. Now, sometimes on the AP test and on your test that you'll have in here, it's going to have you plug in a value into your implicit, and it might be easier to plug in now before simplifying for the dy dx. Now, this one's not too bad to simplify, but sometimes like it'll give you this really long implicit, and you've got e's and ln's and things like that, and the x value you plug in is like 0. And so a lot of stuff cancels. And so it doesn't matter when you plug in, you just have to. So I'm going to plug in my x and my y now before I get the dy dx by itself. I think it does make the problem a little bit shorter. All right, so what am I going to plug in for x? 1. What am I going to plug in for y? 2.
No, do your work.
Yes. All right, so then I got 2 plus 16 dy dx. Now, how would I get dy dx by itself? What would I do next?
You just divide by, or you subtract 2.
Minus the 2, and then divide by 16. So what would your slope be? Negative 1/8. And then you just put that in the y minus 2 equals negative 1/8 x minus 1. And that's my tangent line equation.
Hint trig identity.
We're going to skip the trig identity one.
So
Yeah.
we're not doing it at all? Cross
Nope.
out?
Yeah, you can cross it out.
Yes.
Is it not like on the test room?
Okay, Cameron, shush. I don't know if it is.
The
figure-
trig identities are very rare, like almost never. I wouldn't. It's not something that I would worry. There's so many other more important things to focus on that we're not going to do the trig identity. Okay, the next 2 questions are old FRQ questions from AP tests. So you'll start seeing patterns for these implicit questions. You have got to know how to do them. All right, they're like the easier FRQs too. Like they're the ones that you want to be able to get the entire thing right. Like they are totally doable, but you got to know how to do implicit. So this one, I think it had A, B, and C. I think the part D on this one we haven't quite learned how to do yet, but this was most of an FRQ. I can't remember what year this question was on it. But it says, consider the curve given by y squared equals 2 plus x times y. Show that dy dx equals y over 2y minus x. So it's giving me the derivative, but what it wants you to do on A is it wants you to show why that works. So we're going to take the derivative and we're going to show that dy dx is this. Does that make sense? Okay, so the work is your answer. So you have to show your work. So what's the derivative of y squared?
2y.
2y. What's the derivative of 2?
But you don't have to put the dx.
Oh, yeah, you do. Ooh, almost forgot it.
I remember my first time.
The derivative of 2 is nothing.
Right, so the 2 goes away. The derivative of this 2 here goes away is nothing. What rule do you have to use with x times y?
The
Product rule.
But it's just
All right, so product rule is the first function, which is x. Derivative of the second.
So 1 dx, dy, dx,
Mm-hmm.
then plus,
plus
Y.
You're doing too much.
and then 1.
Yep.
Child,
x
anyways,
to the
so.
x.
All right, so from here, we got to move anything with a dy dx on the left side. So this has a dy dx and this has a dy dx. So we need to move the x dy dx over to the left. So I'm going to have 2y dy dx minus x dy dx equals, and then this y here is staying on the right side.
I don't like this one.
Okay, so once I did that, everything on the left has a dy dx.
So we take 1 out.
So I can take it out. And I'm left with
2y
minus
minus x
x. So 2y minus x.
equals y. Divide by that.
Mm-hmm. And so then divide all that by 2y minus x.
And then dy, dx
Do you even need to keep going at that point?
y.
Yes.
Um,
2y.
it might be a good idea just to like state it.
Wait, so.
To state it exactly how it's stated here. Just to
whenever
finish it out.
Says that the state that it. Where did we get the 2 on like the very first one?
This 2,
Yes.
the derivative here, 2.
Oh, and so then we just put that right there.
Mm-hmm.
X.
So they didn't even care about x's like everywhere. It's like here to.
You're probably going to want to be a little bit more in line on the if it says show and like the work is your answer, you're wanting to make it so they can follow. You'll have a lot more space on the AP test though. Like they give you 4 times the amount of space you might need. So they'll give you a nice big box. Okay, so that's it for part A. A lot of times the way the scoring works for these implicit, and we'll talk about scoring guidelines when we get closer and we look at more FRQs, but they will give you a point for doing implicit. So if you could get like this first step right here, where you just take the derivative using the dy dx, you get a point for that. And then if you can solve for dy dx correctly, that's where you can get another point. So a lot of times those are 2 points. And if you can just do implicit, even if you do it kind of wrong in some ways, they'll give you a point for it. Okay. So on part B, it says find all points x, y on the curve where the line tangent to the curve has a slope of 1/2. All right, well, what tells me slope? Derivative. So what am I going to do with my derivative?
Plug all the points in.
Set it equal to what?
Set it equal to 1/2.
To 1/2. Because I want to know when is the slope 1/2. So I want to know when is the derivative going to be 1/2.
So when it says find all points, you're not gonna find more than like 2 points, right?
Probably not. It's probably just 2.
Okay, because that confused me on the last test. It was like find all points. I was like,
It might be like 1 or 2. All right, so on this one here, if I want to finish solving, I'm going to cross multiply. So what is 2 times y?
2y.
And 1 times 2y minus x.
2y minus x.
All right, then what would you do?
do you move the 2y?
What happens when you move the 2y over? They cancel,
X equals 0.
so x equals 0.
That's negative.
If you divide by -1.
It still becomes 0.
All right, so I've got x is 0. Am I done?
No.
No, because it wants the point. So it wants the x comma y. So you have to go back and figure out what y is. How do I do that? Plug in the x into what?
Or derivative.
Not the original.
The original.
Yep, so I'm going to come back up here to the original. So this guy right here.
Is it plus or minus
So y squared equals
2 plus 0 times y. So y squared equals 2 plus 0 times y. In place of the x, I put 0. All right, now what is...
Just cancel.
Yep, so this is going to go away.
Then
Y equals 1.
Yeah.
Wait, what's square root of 1 or square root of 2?
Square root of 2.
Square root of 2.
Minus square root of 2.
Yep. All right, now, I'm pretty sure if you had gotten those values, they'd give you credit on the AP test, but it is a good idea to write your answer how they want you to, like, how it asks for it. So since it asks for the coordinate points, x comma y.
Dylan Ziegler, please come to the front office. Dylan Ziegler.
Yeah.
Hayden Winter, please come to the front office. Hayden Winter.
No, it's not. That's why these are very doable FRQs. What's up?
I have something for you.
What is it? Is it $10?
You know, speaking about money,
No, but you paid 30.
Huh?
You paid 30 already. Your sister did.
20?
Who are you?
Oh.
Did Tadiwa come? Tadiwa, one of y'all came this morning and paid 30. I don't know.
Just go with it.
Yeah, so you only owe me 10.
Okay. Promise?
Yeah.
What?
Student council dues.
Why'd you turn it away?
You can give it to
No,
us.
I didn't like. Don't give it to her.
Don't give it to
Yeah.
him.
You owe me $5, by the way.
I already paid you $5, didn't I? I haven't? Okay.
Why did
Cause-
Tina get $30?
I don't know.
This is interesting.
Yeah, he's literally.
What are you doing? Just put it on my desk. I'll put it. I don't want you to know where my.
You're cooking the
I don't want you to know where my thing is.
Of course I am.
He's like, where's the?
Well, I mean, I'm gonna get more money.
He's creating funds that we need to put money towards in the fund. Can we do a fundraiser for you?
I know how to spell it.
Wait, yeah, Elijah, how much is your quota for this now?
Okay. I'm almost done, but we got to keep going. And remember, you need to focus because these are actually really, really important questions.
Let's go.
We're almost done. All right, on part C, it says show that there's no points, x, y on the curve where the line tangent to the curve is horizontal. So what do you know about horizontal lines? What? The slope is 0. So we're going to do a very similar situation here, and we're going to take my slope, and we are going to equal it to 0. Now, yeah. When you equal this to 0, is that the top or is that the bottom?
Top. Bottom. Top.
Top.
I said top first.
Yeah, you did.
And then you were like, eh.
I made a face it, so I was.
Oh.
She made a face of kid though.
It's because you're staying.
All right.
Do not bring up the first.
So when you are setting your function equal to 0, I care about the top. Because if you multiply by the denominator, right? If you would multiply by 2 minus x on both sides, what's 0 times 2y minus x? Still 0. So all I care about is the top. So anytime y is 0, my slope's going to be 0. Right. But it's telling me that there are no points on this curve where that actually happens. So what am I going to do with y equals 0 to show that that doesn't actually work? Plug it in. So just like we did on the other one, we're going to plug it in to the very original. So we're going to plug it into this guy.
0 squared
That's not true.
plus x to the 0, which just cancels out.
0 equals 2 D and E.
Yep. So 0 squared is 0. X times 0 is 0. So you're just left with 2. And does 0 equal 2?
Probably not.
No. And so it doesn't work. And so this is what you'd have to show that this does not work.
No.
No, we stop.
Yeah. And you can tell.
Don't
Okay.
bring up
Well,
the-
no, we have one more question.
I thought there was a lot more on this back page. One more question, but it's 4 parts.
Yes, it is.
It's 4 questions.
All right. Last one. So this is a full FRQ question from an old AP test. So like start to finish, a full 9 points. And it says consider the closed curve on the XY plane given by this guy right here. First step, show that dy dx equals that. So we're going to take the derivative. So what's the derivative of x squared?
2x
Plus,
2
plus,
4y cubed dx.
Okay.
plus,
4 dy.
equals 0. All All right, so what do I need to move to the other side?
2x, 2,
Yep,
4y. Oh, wait, no. And
just the 2x and the 2. Yep.
she asked what to move, and now you're telling
You
me
said
what
the
she-
wrong answer.
All right, so we're going to minus the 2x and minus the 2. After you do that, everything on the left should have a dy dx. So we can take out a dy dx, and I'm left with 4y plus 4. So notice I didn't take out the 4. I just took out the dy dx.
You forgot the cube on the.
Oh, thank you. All right, what would I do next?
You would divide by
Yep.
that.
All right, so I get dy dx equals negative 2x minus 2 over 4y cubed plus 4. All right, so when I look back at my problem, is that what it wants me to match it to? No, but does it simplify to that? Yes. So all we got to really do, you don't have to show your simplifying steps, but you do want to actually put that it equals what they want you to show it equals to. So make sure your final answer matches with what they want you to match it with. So from here to here, it's just simplifying, which you don't have to show that, but you do have to put equals and then their final step. Is that okay? Okay, so that's part A. And like I said, that's probably 2 points there. Just doing implicit and then solving and getting it by itself. All right, on this next one, it says write an equation for the line tangent to the curve at the point negative 2, 1. So what 3 things do you need for tangent line?
yx.
Yep. Which ones do we know?
Negative 2 is x and 1 is y.
Yep, and how do I find the slope?
Derivative.
The derivative. So negative, what am I plugging in for x?
Negative 2.
Plus 1 over 2 times what am I plugging in for y?
1.
1 cubed plus 1. All right, that is going to simplify down to 1/4. And so I'm going to write the equation of the tangent line. So y minus equals 1/4 x plus 2. All right, so let's talk about the simplifying real fast. Let's say you come across this fraction right here and you're struggling to simplify with the negatives. You could put this entire fraction unsimplified in the m spot and still get credit. All right, so you do not have to simplify this down to 1/4 or you're like, I know I'm going to mess that up. Like, I know I'm going to add something stupid. You can just take this and put it in the m spot and they would be fine with it. So you do not have to simplify. You can leave it alone like that. But you do need to write the equation of the tangent line because that's what the question is asking for. So you do need to have this.
You just need to know where to plug it in.
Mm-hmm. Yep. So this one was probably 2 points. They probably would give you a point for getting the slope, which is either as a 1/4 or just plugging in your values correctly, and then a point for actually writing the equation of the tangent line.
Next one.
Okay. Find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. So what do you know about the slope of a vertical line? It what? Does not exist. Yes, it does not exist. All right, so
Please tell me that's it.
no. All right. So if I'm going to take my derivative, which is negative,
Set it equal to d and e.
Set the bottom.
yeah, setting it equal to d and e, that's not super helpful. So what has to happen for this to be d and e? The bottom has to be 0. So we are going to just set the bottom equal to 0. So 2y cubed plus 1 equals 0. When you divide by 2, you still get 0. What would be your next thing? Minus 1. And then it's a cube root, so it'll be negative 1.
No, negative 1 times negative 1 is positive 1.
because it's a cube, 3 times, that would be negative 1. All right, but am I done with that problem? No, because it says point, so I got to find the x too. So where am I going to plug negative 1 back in? Yes, into the original. All right, so x squared plus 2x plus negative 1 to the 4th plus 4 times negative 1 equals 5. All right, so I'm going to zoom in here. So what I wrote in orange here, this is the original function. I plugged negative 1 in for the y value. So I get x squared plus 2x. What is negative 1 to the 4th power? Positive 1. And what is 4 times negative 1? Negative 4. And I'm going to move this 5 over to the other side, and I'm going to minus 5 because I know I'm going to have to equal this to 0 because it's probably going to be factorable. All right, so if I combine all my constants, I get x squared plus 2x minus what?
8.
Minus 8. All right, so what two numbers multiply to give me negative 8, but add to give me 2? 4 and negative 2. So that means my two x values are going to be? Negative 4 and 2. And so my coordinates are going to be negative 4 comma negative 1 and 2 comma negative 1. All right, and then the last problem for today. Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? Explain your reasoning.
I'm just gonna say
So x would equal.
You have to explain.
no because I said so.
All right, so let's talk about horizontal tangent lines. What is the slope of a horizontal tangent? 0.
Y is going to be 0.
And so when I'm talking about this guy being 0, I'm going to take my derivative. And equal it to 0. Now, when you're equaling this to 0, I just care about the top. I don't care about the bottom. So I'm going to say that x has to be what? Negative 1. So if I have a horizontal tangent, x is negative 1. Okay? If I'm intersecting the x-axis, what is special about the y value?
0.
Y is 0. So we're going to see if this coordinate point exists. Does negative 1 comma 0 work for my function? So I'm going to plug it in. Okay, so negative 1 squared plus 2 times negative 1 plus 0 to the 4th plus 4 times 0 equals 5. Okay, so what's negative 1 squared? 1. 2 times negative 1?
Minus 2.
And then plus 0 and 0. And does that equal 5?
No.
No. So no, not possible.
How do you explain?
If your work, yeah. If your work is nice, then that works. All right, so are we good? I will let you have a homework day tomorrow as long as you're actually working on homework. If you don't work on homework, I will never give you another homework day again.
So if we finish our homework?
Yeah, you can just work on your homework all class periods.
Sitting at your desk all class.
Oh, then you can do something else.